Okay, so today what we are going to do is, so let me go back. So today we will focus on the smart contracts, continuing the discussion on the smart contracts, but we will focus more on the challenges in the smart contracts, especially what kind of the problems you can get, because smart contracts. Even though there is it's a programming language, they are directly dealing with the money. So that means you have an adverse effect. So that's why we look into the focus on the challenges of the smart contracts, and also at the same time look into. Okay, my voice is not audible. Just let me check. So, am I audible, or you have some problems in hearing me clearly?
No, sir, you are audible.
Okay, so maybe one student is saying that. So probably maybe the internet connection on his side or something like that. So we'll focus more on the most part of the lecture on the challenges that can are the kind of problems you can get in smart contracts, and also at the same time we will look into some of the tools that can benefit dealing with those challenges. And then we will briefly discuss about decentralized autonomous organizations. It's a concept loosely being framed around decentralized governance and other similar practices, but let us also look into them what they are. And today I have some visitors from Norway, so I have to take them for dinner. So probably we will close before 9:30 in Indian time. So 5 minutes before 9:30 we'll close down, and if we still have some slides, I will cover it in the next session. Right. So this is the overall outline for this today's lecture. So we look into the challenges of the smart contracts, and at the same time, what are the solutions or what are the tools we can use to address them. And again, we go along the life cycle of a smart contract. We have seen in the last lecture that smart contracts life cycle can be split into four categories, like the creation challenge and the deployment. It has the creation phase where you develop the smart contracts, and deployment phase where you will deploy the smart contracts to one of the blockchain platforms for execution. And then you also have the execution phase where where the instance of the smart contract is instantiated, or you can say invocation of the smart contract happens. And then finally, we have the completion challenges when the smart contract finishes its functionality, and then you archive it on the blockchain and things like that. And we look into the challenges in each specific life cycle. And then we will look into what is DAO, decentralized autonomous organization, and some definitions around it. And we will also look into one of the first initiative on the DAO, like the DDAO. So this is a company which was started on the principles of the decentralized autonomous organization. It's a crowdfunding company, and but bad things happen. So it was built on Ethereum when Ethereum was 1 year old. Then attack happened on the Ethereum, which stole most of the money from, which stole a lot of money from the DAO attack. So we'll also look into details of the DAO attack. Okay, so first of all, why it is important to look into the challenges on the smart contracts. We know, of course, we haven't coded smart contracts. We at least have a brief understanding that smart contracts is nothing but the programs, or you can say the contracts written in a programming language. And we will see in the coming lectures, you can use different languages. Most of the time we use Solidity. That is the language which is used for Ethereum blockchain, where we can develop smart contracts. And you can also develop smart contracts in different languages. For example, Go language, and also JavaScript and many other languages, right? So basically, if you think about it, it's nothing but smart contract is nothing but some kind of artifact developed in a programming language. So some kind of software, right? So you have a programming language and you write a software, and this is nothing but a smart contract is nothing but a piece of software, right? Then why it is important to look into why we are worried about this the challenges of the smart contracts and things like that. If I compare the smart contracts with the piece of software written in another programming language like C# or Java, we have some I can say important things with the smart contracts, which don't have with the other languages, right? So when you develop a small piece of code or some software for example, using the regular object-oriented programming languages, most of the time you are trying to model a functionality, or most of the times you are trying to develop a code or a small system which can address some functionality. But in case of smart contracts, so most of the times we deal with money, because we are developing, no doubt we are developing some functionality here, basically encoding the rules from a contract, or you can say encoding the rules or the understanding between different parties into a formalized contract and things like that. But underlying, the thing is, most of the times it directly deals with the money, right? So let me see if I'm recording, just 1 second. Yeah, I'm recording, so that's good. So most of the times it deals directly with the money. So that means if we are not careful, if we write buggy code, in case of normal programming languages, probably it won't happen much, because many times we don't write very mission critical software systems. We write most of the times normal software system. Probably you will identify a bug and you will fix it and you will redeploy the application. But it's not the same case with the smart contracts. First of all, any small lapse in small contract, you can say bug in smart contract, can lead to a financial loss. So for example, in 2016, the 60 million worth of the Ether was stolen from Ethereum. And this is part of this DAO attack, which I will talk about it later. So it was legally stolen. So you can say that exploiting a vulnerability in the one of the vulnerability in the smart contracting language, right? So that was one of the biggest challenge. So that means any lapse can lead to huge financial loss. Depends upon how much financial transactions the contract is involving. The second important thing is, when I compare with the software, piece of software written by developed in object-oriented programming languages, and smart contracts written in some kind of language, right? So in case of normal applications, let's say that if you find a bug, you can fix it, you can compile the code, and you can redeploy easily, right? Most of the times, the redeployment is not a big issue, right? So since you are the one who is maintaining the application, probably you will give notice to users, and then you will simply override the application. But that's not the same case with the smart contracts. Once the smart contracts is deployed on the blockchain, then it becomes public and decentralized. And we have seen that since it lives on the blockchain, it is hosted on the blockchain, it is immutable. So that means if you find a bug in the smart contract, then you have to redeploy it completely. Again, what is the problem here? Maybe you will pay the redeployment fee. That is one thing. You will need to pay one more time the charges for deployment. That is not the biggest issue. Imagine that you have several stakeholders, right? You are developing a contract, and your contract is interacting with several of your partner companies. And if you redeploy a smart contract, and then you have to inform all the stakeholders. So for example, let's take that you have 3 companies involved in this smart contract, and you have to inform them that the contract we are revoking, or we are installing a new version of the smart contract for the same functionality, and they have to also do something on their systems. For example, if they have some systems interacting with the smart contracts, they have to compile code, they have to redeploy the code, they have to test it on themselves and things like that. So that is the reason it's a very complicated process, because of immutability on one hand, and it's also critical because it deals directly with the monetary and the financial assets underlying it. So that's why we focus a bit more time on looking into these challenges. Some of the challenges you might find it is very abstract, so you might not maybe make sense out of it at this point of time. But if you are really going to work with the smart contracts in your afterlife, for example, after graduation and things like that, and this knowledge will be really useful and important. Okay, so let's go further. So basically, we look into the challenges. We have categorized the challenges along this line. So creation, we have readability, functionality, functional issues, and things like that. And you can see here, these are the different tools, or the techniques, or the scientific methods developed by the computer science departments to handle these kinds of the challenges. Right. So, and again, this is from this research article. If you are going to work in the smart contract domain, or if you're going to work with the blockchain, then you should read this article, right? So to get a thorough understanding on smart contracts. Okay, so let's look into the creation challenges. If I recap on the what is a creation life stage in smart contracts, basically, let's say that we have some rules between different stakeholders in the traditional contract, and then the creation stage is where we convert these rules into a smart contract fashion, right? So we have seen that there will be a lot of negotiations between multiple parties, and then we design the smart contract, implement, and you test the smart contract that it follows the functionality and what we wanted and things like that. One of the challenges is, so users have to code their own contracts and deploy on various blockchain platforms. Essentially, it's since it is immutable, you have no chance of updating the contract. You have to deploy a new contract. And there are two important issues that can arise in terms of the creation challenges. One is the readability. The other one is different functionality issues. Let's look into them one by one. So what is readability issues? If you again take the example of writing a smart contracts on Ethereum platform, as I was mentioning before, you could use several languages to write the smart contracts. For example, you can use Solidity, you can use Go language, and you can also write in Java and these languages, right? So if you are dealing with a big organization, and then you will be simply ending up with the different contracts written by your partners, and some of them written by you. So if the contracts are written by you, you have the source code, right? But if the contract is not written by you, then you only have the compiled code. So let me elaborate what happens in case of smart contract development, right? So basically, you will use one programming language to write a smart contract. So in this case, let's say Ethereum, right? So you have developed some functionality in a contract, like any kind of programming language and a piece of software. Then you compile the code. So then it will generate a compiled code. So now you have a compiled contract, right? And then you will deploy them. And then finally depends upon the virtual environment in which it is running. So for example, in this case, Ethereum virtual environment, let's say EVM, and it will be compiled to some kind of bytecode instructions. So these are the instructions which are specific to the underlying hardware architecture. So basically, so that you can execute the conditions and the logic imposed in the smart contract, right? So during a period of time, you might be ending with a lot of executable code, for example, and a lot of also source code with the different versions and things like that. So maintaining these programs over the long time is a big challenge. So, and then if you have the source code, then you can easily analyze it, or you can say keep track of the source code over the period of time. But on the other hand, if you have the executable code, let's say that you only have the executable code. Let's say that you are consuming smart contract, and one of your partners has developed a smart contracts, and then they only provide you the executable code, right? So, or you can say you have downloaded the executable code from a blockchain, the smart contract code or something like that. So let's see some of the challenges and what we can do about it, right? So, for example, on the other hand, so the deployment of the smart contracts, for example, on Ethereum has increased many times. So, for example, it jumped by 300% times. So, And now we have approximately smart contracts around 4.6 million. And you can see that most of the smart contracts, they don't have the source code released, right? Right. So you develop the code. It is like any kind of software system. So for example, you develop an application in a programming language, then you will produce an application, right? So maybe GUI or without GUI, yeah, it doesn't matter. Basically, what you get is you get an executable. And you will deploy this executable on one of the target servers or a platform, and then you can execute the program, right? Similar to that, you have the smart contracts. Only around 70%, only around 20-30% of the smart contracts have the source code available publicly, right? So this is a big problem, because if you want to do auditing on the smart contracts, whether the monetary has been, whether there are any misappropriations happening and things like that. So you have big issues in analyzing them, because you cannot easily make sense of the executable code. So one of the tools, you can say, it's called Erase, which uses the reverse engineering. So this also working similar to the normal software code, where you can use tools to analyze the compiled code or even the executable code, and then you can reverse engineering to basically to reconstruct the source code, right? You don't get the same source code if you reverse engineer, but you will get a code equivalent to the original source code, because it is impossible to get the same source code, but basically you will do some heuristics on that. Similarly, this tool will reverse engineering and convert the executable code into some human readable format. So for example, like this, right? So like for the like while loop and other kinds of things, so that you can understand the source code. And the functional challenges, if you look into the functional challenges, three important challenges you can see. The re-entry problem. Again, this is mainly common across many, for example, Ethereum and other kinds of the platforms. So what is entrance problem? So for example, let's say that you have a function in a smart contract, right? So it should be robust enough, even it is interrupted and rerun again, right? So let's say that you can also compare a smart contract equivalent to a web service, right? I don't know whether you have the understanding of web services. Web services is like a small web programs which are consumed automatically by the machines. It's a protocol for machine-to-machine communication, right? So where you can call a web service to do some job, and then to get some functionality and things like that. So similar to that, when you make a call to the smart contract, a function in a smart contract and things like that, if it is interrupted in the middle, then you should be able to run again without any side effects, right? So this is a big important issue. If you are not if you are not re-entrancy safe, you can say, then what happens is the malicious users can easily exploit this vulnerability, and then let's say that the function call transfers some money to the another account, then you can easily run many times to steal the money from the account. So this is one of the issues. And then another issue could be like the block randomness. So for example, many applications based on lotteries and the pool and other kinds of things, they depends upon the randomness of the generated blocks, right? So they choose the block randomly and things like that. And you can easily influence or you can easily influence the outcome of such heuristics by creating a lot of easily deviating attacks or something like that. The third most important thing is overcharging. What is overcharging? So that means when you write a smart contract, probably you might be paying more gas than you are supposed to pay because of the under optimization of the smart contract, right? So let's look into the overcharging the problem. So 90% of the contract. So as we discussed previously, we have around 4.6 million contracts by the year 2022 or something like that. But 90% of the real contracts have suffered from the gas costly problem. What is gas costly problem? So when you write a smart contract, it has some operations in it, right? Calling and doing some functionality and executing some code and things like that, right? So all these operations, they will cost some the gas, right? So the execution fee for the smart contract is computed by this. So gas price, it is nothing but the price of the gas, or you can say in this case, price of ether according to the market price. And the gas cost is nothing but the sum of the operation units you require for to execute the smart contract, right? So for example, let's say you have a set of operations you perform in the smart contract. We calculate for each operation, and then we find out what is the total amount of gas you needed for these operations, and then you multiply the price, then you will get this execution fee. Not only that, on top of it, you also pay the gas when you are deploying the contract, right? So, and that is proportional to the how much is your the size of the bytecode or the compile code and things like that. So all these things can result into paying expenses and things like that. And this is a one tool which called the gas reducer. Basically, you give your compile code to the this tool, and then what it will do is it will try to analyze and what are the redundant places where you're paying more gas than you're supposed to do, right? So basically, it tries to look for the under optimized the construct and try to come up with solutions saying that okay, maybe here you are making a unnecessary loop and things like that, and then probably you can go into this direction, so where you can save the gas cost and things like that. So this is a tool which operates on the bytecode, but it gives you how to optimize your contract so that you can end up paying the less gas, less execution fee. Okay, so let's look into some of the execution challenges. Some of the deployment challenges, right? So again, in the deployment phase, what you do is you compile the contract, and then you have a compiled code, and basically you will try to host it on the blockchain, right? So for example, if you write a contract with Ethereum Solidity, then you will place it on the Ethereum blockchain and things like that. And as we discussed previously, because of the immutability nature of the smart contracts, when once we deploy the contract, we cannot change it, right? So therefore, you also need to check for potential bugs. Why it is important? Maybe your smart contract might be interacting with the different parties as part of its logic, right? So for example, let's say that you have several, let's say that you have 4 stakeholders involved in the smart contracts, like the other companies. And then what happens is your smart contracts need to interact with those systems, right? Then you will have the interaction patterns. So if you don't check very clearly, then it could lead to some kind of potential losses, or maybe it can be exploited by the malicious behaviors and things like that. So that's why you need to, at the time of deployment, you need to check for the correctness of the contract, and also you need to check for the dynamic control flow, right? So how exactly a contract will be executed based on different control flow conditions which you have in the contract. So that is the focus of the deployment challenges. So, and then how do we check the contract correctness, right? So basically, this is like trying to verify whether the contract is how can I say, functioning, are executing what we are supposed to do, right? So that means whether the functionality is as intended as we thought of developing it. And so these kinds of things you can do it, right? So, and again, you can apply different types of analysis. For example, let's say that you only have the bytecode, the compiled code of smart contracts, you don't have any source code for it, and then you can use bytecode analysis. So tools which can understand the bytecode and then reason about the functionality. If you have source code, then there are certain tools, and you can also use ML-based approaches for the ensuring the correctness of the contract. Let's look into some of the approaches. So this is called the bytecode analyzer. So it is called Ether, and basically, given a smart contract, the bytecode. So what you can do is you can use this code to identify the execution flow graph, and it can easily identify whether there are any security bugs, especially which could be exploited by the malicious users to take advantage and things like that. So this is mainly focused on trying to identify the potential security bugs. So that is one tool. And then if you have the source code, then you can use a tool, beautiful tool, which will compile the code to the F star. F star is nothing but a functional programming language similar to F sharp. So basically what it does is, let's say that you have a Solidity source code, and then it translates the Solidity source code into F sharp constructs. And so you will get a equivalent F star code of the same contract. And then you can also compile the, let's say that you have a compiled version of the bytecode of a smart contract. Then also you can, it can be translated into the EVM equivalent of the F sharp. So basically it is also in the F sharp language, and then it can verify the functional correctness and also runtime safety. So that means whether there are any security bugs or something like that, right? So these are the two important tools which work on the formal verification, which could be used for verifying the smart contracts. Then you can also use ML-based approaches. So for example, people have been using ML-based approaches, and nowadays in the recent years, maybe for last 2 to 3 years, large language models have been quite popular, right? You might have heard about Autopilot, Copilot, the Copilot, and this was built based on the building on the large language models and things like that. Now it can fix bugs in the programs and things like that. So smart contracts is nothing but a small programming language with some constraint and things like that. So maybe in the coming years, no more than 1 or 2 years, probably you can find easily a large language model which can help you to find bugs and other kinds of things in fixing in the program side. So, and how many of you use ChatGPT and other language model for finding bugs or for programming? So are you allowed to use large language models? Yeah, please go ahead. There was one hand. So is it allowed in the universities? That's what I'm saying.
Yeah, yes, sir.
Okay. So it was quite convenient, and we also encourage students here to use them. And people have been using for maybe writing, getting small snippets of the Python programming and things like that. So yeah, so there will be a lot of automation in the coding, and especially, and the coding profession has been endangered by the large language models, right? So because you can generate a lot of code very easily and things like that. So smart contracts is also not going to be a big issue in that, and you will have more and more tools developed for verifying the correctness of the smart contracts. So let's see what is dynamic control execution. So basically, let us say that we have a contract, right? And your contract might be executing in different environments. Let's say that you deploy it, and then let's say that your contract runs for several years, right? So, and then because it has to be executed in different environments, maybe the miners and things like that. So, one of the important issue is also to verify your contract or check your contract across different virtual environment, right? So this is one good tool called EVM Fuzz, which is basically what it does is it will take your smart contract and it will simulate the execution of the contract across different virtual environments of the contracting. Like, for example, if it is Ethereum, it will use different EVMs, different versions of the EVMs, and execute the simulate this execution in each EVM environment and try to find the bugs or inconsistencies. Maybe it's not a bug, for example, an inconsistency. Let's say that you are using a programming construct which might have been deprecated in the future versions, right? So that could be inconsistency. Maybe you are using an advanced construct from latest version of the EVM, and maybe the miner might be running a older version of the EVM. So these kinds of inconsistencies it tries to identify. So this is also a very good tool called EVM Fuzz, which actually basically simulates your contract execution across different EVM environments. And then it will identify like, okay, you have these parts are having problems, so maybe this is the problem and things like that. It will hint and it will give you the kind of inconsistencies you can get in across different stage information. So let's look into the execution challenges. So again, what happens in the execution phase, as we have seen in the smart contract lifecycle? So basically, we have the contract, and we will invoke the execution of the contract by calling into it and things like that. And then there are several issues that can be arise out of the execution stage. One of the most important things is a trustworthy oracle. Let us talk about it, and also the transaction order dependency, which is also another issue which we might get, and finally execution efficiency. Let's look into these two things, right? Like what is a transaction oracle? Let's say that smart contracts they rely on several real-world information. For example, let's take a simple case. Let's say that we are developing a smart contracts for betting in a Euro Cup, right? So basically, people can bet on outcome of a championship. In this case, let's say Eurobet or something like that, and then based on the outcome, for example, which team has won the cup. Let's take example France and Germany and things like that, right? You bet on Germany, and then if the German team won the European Cup, then you should get money, right? So, and similarly, if you lose, you will. If it loses, you will lose money and things like that. But the main point is that the smart contract somehow need to get the information saying that who has won this European Cup, right? So this is an external information which you don't have at the time of the development of the contract, or you don't have at the time of the deployment of the contract, or you will only have, or even at the time of execution, probably you don't have it. You need to get this information somehow. You need to pass the information somehow to the execution of the smart contract, right? So if the smart contract gets this information saying that who has won this European Cup, based on that, it will execute accordingly. So, for example, let's say in this case, the team on which you put the bet has won the European Cup, then you should get money, right? So then it will transfer money to your account and things like that. So how does it know the outcome of a real world event? Because we cannot hard code it during the development or deployment phase. So what we do is we use Oracle. Oracle is nothing but some kind of agent which gets information from the outward events. So basically, you can simply assume that Oracle is nothing but something which will call a web service outside and get the information saying that, okay, who has won this cup and things like that, right? This poses a big challenge because let's say that we have developed a smart contracts for betting on the European Cup. And let's imagine that our smart contract gets this information from a web service, right? So let us say that I have a web service which is hosted at some location, which will give you the real world outcome, right? But you can have easily create some kind of cybersecurity attacks. So, for example, have heard about this DNS spoofing? So, what happens is you can attack the local DNS server, and then you can easily misguide the DNS server to redirect to some of the malicious site. So that's why when you are actually, you might have heard that this type of DNS spoofing or DNS cache poisoning attack has been implemented and has been used to hack the many internet banking websites. So that's why when you log on to your internet banking, it always says that look for the logo and look for the URL and all these kinds of things, right? So these are the some of the attacks which you could create on the DNSs of it. So for example, let's say that I'm interacting with Citibank. Let's say that I type the URL saying that www.citibank.com. And if the local DNS server is spoof or poisoned with some kind of attack strategies, then it will direct me to the fake website or something like that. Similarly, you can also create the same kind of the attack on the real world outcomes by using these techniques. Right? So that's why getting information through the oracles is a big challenge. There are some strategies. So, for example, TownCry is some kind of methodology proposed to address this challenge. So that means how do we get trustworthy information and things like that. So basically, it will work in a secure environment, and also it will extract the information. No doubt, it will go to the HTTPS and get call the web services on the internet and get information. But on the other hand, it will also document and validate this several things. So that's why you will get trustworthy information and things like that. And again, these functionality, which is called TC, will also run in a software guarded execution. So that means execution environment, you can say sandbox environment, which cannot be easily hacked, or which can protect from the malicious behaviors and malicious attack. So these are some of the techniques which can be used to get reliable information. On the other hand, let's say that the information is provided by your secure servers. So for example, in this case, we are relying on a service which is controlled by us. Then we don't have big issues, because since we have the control over the service, and then we can easily make secure the services controlled by us, and then you might not have a big issues. But if the Oracle is getting information from the third-party sources, then you need to take care of these kinds of things can happen. So there are some certain strategies which can be implemented to tackle these the trustworthy challenges. Then another challenge which can happen is transaction order dependency. So what does it mean? So let's say that we have the user send transactions to invoke the functions in the smart contract. So that means users will call the smart contract, right? Using transactions and things like that. And the miners will pack these transactions into the blocks, right? We have seen while discussing the blockchain, many times you might get, how can I say, inconsistency in the blockchain, right? So you might have competing blockchains, or you can say you might have forking happen in the blockchain. And then because of the forking and other kinds of things, the transactions might be not deterministic. What does it mean? Again, let's take the example of the Bitcoin. We have discussed it last time when we are discussing about Bitcoin, saying that at least you need to wait for 6 blocks after your transaction is included in a block to make sure that your transaction will end up in the longest chain, right? Similar to that, the transactions can end up into different blocks, which can create some problems in the which can create some problems if you have sequence of operations which require sequential execution, right? So that means you might have the transaction ending up into different the blocks, which can create some problem. This kind of uncertainty can cause inconsistency in the order dependent patterns transactions. So for example, let's say that we have a smart contract. Again, this is a very, very simple use case, right? We have a smart contract variant, let's say X, and LS sends a transaction to increase the X value in the smart contract by 1. On the other hand, Bob sends a transaction to invoke the smart contract, which will multiply X by 10. Right? So let's imagine that both the transactions are happening at the same time, or more or less at the same time. Then due to the uncertainty of the transaction, the final outcome could be like either X plus 1 or X multiplied by 10, right? Depends upon the which transaction got executed and which transaction got accepted and put into the block, right? So these kinds of things can happen. This sounds a bit like inconsistency, the consistency property in the database management system, right? So, for example, let's say that now you are in the database management systems. You might have 2 commits happening at the same time, which can create some consistency. But in case of database systems, we are pretty good because we know consistency properties. We have some consistency properties, and we know the mechanism to locking and other kinds of things. So we know pretty well how to deal with these kinds of inconsistency in the kinds of database management systems. But in case of smart contracts, we are running in an underlying the blockchain, which might have different ordering consistencies, and that can create a lot of problems. So that's why this transaction ordering is a quite big issue, especially if your the functionality relies on a sequence of operations, a series of operations to be executed in the exact sequence. So what could we do? One simple way is the sequential execution. So what does it mean? So we introduce a design pattern saying that the transaction counter. So let's say that in this case, right? Let again roll back to this LS and Bob's case, right? So what you do is you implement some kind of ticketing strategy. So for example, let's say that LS want to call a function which will increment the X by 1. Then in case of sequential execution, what it does is first call to the function will give it's some kind of number. You can say transaction serial number or something like that. And then when actually update is happening, then LS has to send this transaction sequence number as part of the call, right? Then the execution environment will verify whether both the sequential numbers are equal. Then it will perform the execution. Otherwise, it will roll over. So this is nothing but by using a ticketing strategy, right? Like we can say that before executing the function, the LS got a ticket, and she will send this ticket as part of the call, and so that it will avoid inconsistency like that. This is a simple strategy, which is one of the design patterns normally adopted in the software programming. So this can have easily benefit. The other kind of pattern which we can also implement is defining the contract to avoid such kind of scenarios, right? So then what does it mean? Again, let's take this simple example, multiplying and incrementing the value in a smart contract. So we might resolve to saying that we will implement different functions. For example, increment if multiplied and things like that. So which can take care of these kinds of anomalies which can happen because of the transaction out of the sync happening on the underlying blockchain. Right? So these are some of the strategies which you can use to deal with it. So let's go with the last the challenges, the completion challenge. So what are the challenges we have here? The completion phase is nothing but some kind of when the execution is done, it will unfreeze the wallet accounts and other kinds of things, right? So basically, it writes transactions to the blockchain, unfreezing the digital assets and other kinds of things. One of the biggest challenge here is it is writing some information to the blockchain. And many current smart contract and blockchain platforms, they lack the privacy preserving mechanisms. For example, they still contain a lot of information about the users involved in. So for example, wallet information, maybe they don't have the names in the transaction, but they have the information about the wallets, which can leak information about the users. Right? So these are some of the privacy concerns that can happen. So, and then people can easily see the transactions, and based on the transaction, based on the wallet information available in the transaction, you can easily try to identify who is the user of this transaction and what is happening between here. So, for example, whether the money is transferring from one entity to other entity and things like that, it can lead to a lot of big problems, especially in the domain of privacy and security. Right. So you have two types of challenges: the privacy and security. And also the scams. You can have the scams. Basically, let me give an example: honeypot scam. Right. So they can sometimes you can have a smart contract which try to lure you, saying that if you transfer me 10 ethers, and then if the balance is less than this threshold, then you will transfer back with extra surcharge, right? So you transfer me 10 and you will receive 15 ethers or something like that. And that is a kind of honey spot, basically trying to disguise the people and transfer money. This is not a hoax or something like that. It is happening actually. There are some smart contracts deployed and which contains these kinds of strategies to misguide users and take money, right? So these are some of the challenges. Let's look into what can we do in the privacy challenge. So privacy is a big issue because if it leaks information, and that could be a really big concerning point, right? So there are strategies. For example, I don't know, you might have heard about zero knowledge proofs. Zero knowledge proofs is nothing but a technique. So zero knowledge proof here, right? It's a technique built on the mathematics, right? So so basically it works like this. It doesn't reveal the information completely. It doesn't reveal the data, but on the other hand, it will give you proof about the data. So it's a very hardcore mathematical technique. Basically, it will guarantee you that this is the data range or something like that. But on the other hand, it doesn't reveal the data information. It's very complicated. But the idea here is when you have a contract involving different entities and things like that, what you can do is using this Hawk tool, basically you can compile the contract into two parts. One is the public part, and then other one is the private part, so that only the desired entities can get this hands-on private part, right? So for example, the wallet information and other kinds of things, probably only the miners who execute this transaction maybe get hold of this private part. But on the other hand, the public part is available to everyone. It doesn't leak information. It doesn't reveal information about the entities and wallets and other kinds of things. So you still have the public part for the validation, and the private part for more for transferring the money and other kinds of things. So this is a technique using the zero knowledge proofs, which is a bit complicated procedure, but which is being used, right? So, okay, so let me summarize the challenges. So here we have the readability challenges and the functionality issues like the re-entrancy problem, BRAC randomness, and overcharging we have seen here. And similarly, in case of deployment, we have the contract correctness and also the dynamic flow, control flow. You have some graph-based analysis. So the tools basically build a dynamic control flow graph, and then based on the control flow graph, you can identify whether it has any kind of bugs or the vulnerabilities and things like that. Similarly, execution challenges, you have the trustworthy Oracle, and we haven't seen the decentralized approach. Basically, it will distribute the trustworthiness across different decentralized peers. We have discussed some of the techniques, how to split and share the key across different multiple participants, right? Shamir key splitting algorithm we discussed in the last course or something like that. Let's say that you have your private key. What you can do is you can split your private key into 7 parts, and you can define that any 4 parts are sufficient to reconstruct the key. So these kinds of strategies you can also implement as part of this execution efficiency and trustworthy Oracle information and things like that. And finally, you have the privacy and security and scams we haven't seen. Honeypot is an interesting scam which tries to lure you to transfer money, and you also have some kind of Ponzi schemes which can give problems, right? So, okay, so let's. Do you have any questions? Yeah. So then, HTTPS. What is that? So, is it a question or something like that? Yeah. Please go ahead.
Hello.
Yeah.
Yes, sir. How is the data that is, the Oracle that is taking is verified, sir, whether it is true or no?
Yeah. So that's exactly the biggest challenge, right? So you can, because let's think about in terms of the smart contract. Within the smart contract, while developing a smart contract, you have to believe the information which you receive, right? Other than that, you don't you don't have mechanism to verify it or validate it, right? Because on one hand, you are living the execution environment is very limited, and for example, the programming language also has very limited constructs, right? So the Solidity has very limited constructs and things like that. On the other hand, when you are deployed in a blockchain, if you do a bit advanced validation kind of thing, then what happens is you will end up spending more and more gas, and it will be expensive, right? So in this case, what happens is, where is it? Let me see here. Charge. Yeah, this one. Yeah. In this case, what you do is the smart contract will use some trusted environment. This will happen outside the smart contract environment. So let's say that let's say that I'm taking simplified things, right? I'm not going into all the details and stuff like that, and how secure environments and things like that, because the smart contracts can involve millions of dollars, pretty big sum and things like that. So they need to have very secure environments. So there are some strategies. But let me tell like this, right? So let's say that it redirects, the Oracle calls to a secure URL, which is controlled by you. For example, in this case, the Eurobet company it calls to the Oracle will make a call to one of the services, which is controlled by him, or by the company. And the company this trusted service can go outside and get information. And then at that point of time, you can make a lot of validations, because the trusted server, it's not on the blockchain. It's outside the blockchain. And then it can give some heuristics, and it can also give information about the metadata about the information. So for example, in this case, where it got this information from, and there you can also use some kind of verification techniques. So for example, having a hash value, or you can see using hashing for what you call, we have discussed some guarantee scheme, hash guarantee schemes and things like that. All sorts of things can be implemented here in the external environment. So that's how the Oracle gets more secure data in that process. Any other questions? Okay, so let's go further. Let's look into the decentralized autonomous organization, right? So DAOs. DAO is a pretty loosely based concept. So a DAO is a blockchain-based system that enables people to coordinate and govern themselves, mediated by a set of self-rules, again, deploying on the public blockchain, and whose governance is decentralized. So this is like an idea. For example, let me take an example, Bitcoin, right? Who started Bitcoin? A few people have this idea, Nakamoto and a group, we don't know Nakamoto is an individual person or a group of people and things like that. They started this system, right? Now what happens? Who actually manages the system? Who actually decides when to change the rules and things like that? So it is not the group who started it. Maybe they are part of it, but it is the people who are part of this ecosystem, right? So mostly it's the Bitcoin developer community, because they are heavily involved in the development process of the Bitcoin. So they are the one who are playing a major role when the updates to the Bitcoin should happen, and what type of features they have to implement, and all other things. So this is kind of some kind of decentralized governance, you can say, right? So that's why many people say that Bitcoin is also an example of decentralized autonomous organization. But there are certain subtle differences. People also argue against it because Bitcoin has not started as a DAO. So the concept of DAO is that, of course, the main motivation is the decentralized governance or decentralized organization where things can be controlled in a decentralized manner. But on the other hand, it also says that the governance should be coded in the form of smart contracts, so that the actual true governance, the governance is truly decentralized. So the modern meaning of the DAO can also be traced back to the concept of decentralized autonomous corporation. So this is also a term which was coined around 2008 and things like that, after a few years of the Bitcoin, because people took the inspiration of that, and then they thought of, okay, why don't we, when we build a currency which is decentralized, right, which is beyond the control of the central, the censorship and other kinds of things, can we use this principle to build organizations, decentralized organizations? It could, we already have several decentralized systems, right? For example, Wikipedia. Who controls it? Of course, there are some central entities, but on the other hand, the content happening in the Wikipedia is contributed by the crowdsourced people, right? So it is the people who contribute the content to it. Of course, there are some checking mechanisms saying that whether you are trustworthy and things like that. So not anyone can write to Wikipedia. You need to have some checks and in place. But again, the peer-to-peer networks, these are also the collaborative networks, mostly maintained by the decentralized principles. I have a small video, 5 minutes. Let's watch it. It talks about roughly about what is decentralized autonomous governance and things like that.
For a very long period of time, we've been working as tribes, as hierarchies, and as markets. And that's how we get stuff done. For the first time, we are a truly global civilization. We are now at a point where neither markets nor hierarchies has the capacity to be able to handle the set of problems that we're facing, say climate. At a certain point, if you can't accelerate your capacity for solving problems exponentially, you're done. We have to invent an entirely new toolkit for how human beings can coordinate their sense-making, their choice-making, and their actions, a collective intelligence. And that is precisely what DAOstack is endeavoring to do.
From a very young age, I was driven to the relationship between complexity and simplicity, like how complex phenomena are explained by simple principles. That's what drove me into doing PhD in string theory. I was also experimenting by building an organic food cooperative and a community garden. There was this feeling that cooperation should be easy and can be easy, but there was a missing element. When I met the blockchain, instantly saw the future of how decentralized organization, how cooperative organization would look like at scale.
It started with Bitcoin, and with Bitcoin we were able to transfer value. And the next iteration was really Ethereum to enable all kind of decentralized platform. But there's definitely still a missing piece, and that is governance. How do you do that in a way without compromising on decentralization, still keeping the openness, not fall back to simple centralized decision making? That's what DAOstack is about.
The only answer that has the characteristics of a proper solution will look like a decentralized autonomous organization.
DAOstack is building the complete decentralized end-to-end tech layer for governance of large organizations.
It can be a decentralized Wikipedia, but it can also be a decentralized investment fund or decentralized insurance network. DAOstack is a platform for collectives to self-organize around any shared goal, interest, or values. The first purpose of designing the DAOstack was not to build a specific protocol or a specific application, but rather to build the soil, the ground from which a whole ecosystem can thrive. There is a natural tension between scalability, scaling up the number of decisions a collective can make in a period of time, and resilience, the incorruptibility of those decisions. And we resolve that tension by inventing new collective decision-making process at scale, which we call holographic consensus, whereby small groups can take decisions on behalf of the larger majority, but in a way that guarantees a perfect alignment and coherence of the little group with the will of the greater majority.
With DAOstack, we'll be able to choose the best governance model template and implement it immediately using the DAOstack tech layer. That's the way this world is going to work in the future.
So many of us feel skeptical and feel worried about all the new technology that's being built. We're responsible for creating the value behind the tools we're using.
While each of us and each market and each state is trying to become more efficient and more aligned, if you look at the global scale, we're actually becoming less and less aligned with the collective well-being. I believe that with DAOstack, we'll be able to create greater alignment between the interest and the benefit of the individual and the interest and the benefit of the collective.
It will look like something that can bring everybody together in a way that our collective individual choices and actions actually build to a shared intent, a shared wisdom, and a shared capacity, and keep those things in resonance, keep them in alignment.
That's what we're about at DAOstack, bringing the power of collaboration to the people, making it accessible for all of us to work together and to really feel that we're all on this together.
Okay, so this is about a video from the what you call one of the applications, or you can say one of the applications which promote this decentralized autonomous organization, right? So, but what is it? So it's basically DAO concept, decentralized autonomous corporation, because it has been loosely specified, and these are like a collection of ideas which evolved across different periods of time and things like that. So there are no concrete definitions and the concrete demarcation what is decentralized autonomous corporation and what is the difference between decentralized autonomous corporation and organization and those kinds of things, right? So basically loosely specified. It should be both decentralized and also distributed, right? So distributed autonomous corporations and things like that. And how does it happen? So basically, the governance especially is done by using tokenized the econometrics, so tokenized the economics. So that means each the participants of this DAO, they will have some kind of shares, and then they will in return they will get some the tokens and things like that, which can be used to provide dividends or used to provide power to vote on things and stuff like that. So basically it's about incorruptible with any human involvement, and the basic idea in the pure sense that everything should be written in the form of smart contracts at the time of hosting this autonomous organization, right? So people can participate in the autonomous organizations, and then they can get stock by paying money, or it depends upon the use case and things like that, or you can also do a service, and so that you can get a stake in the company, or you can say a stake to vote for power and things like that. It doesn't mean that always money is linked. It could be like a community service. So for example, take the Wikipedia and other kinds of things. It is built as a collaborative platforms, and open source projects are also built as a collaborative platform. For example, take the Linux distribution. It's completely open source, developed by open source community and things like that, right? Many times, of course, internally, maybe there is some economic angle mixed. For example, you can do a consulting for a company and things like that. But many times what happens is people voluntarily collaborate, and then you contribute to the ecosystem, and that's how your reputation and the power to vote and decide many things will happen. So that is the basically same concept of the DAO and things like that. So basically, you don't need, there is no central one to regulate, but the regulation or governance happens in a decentralized and distributed form. So that is the main idea behind it. So again, as many mentioned, so for example, Bitcoin is one of the first DAO. People argue about it because it was an ecosystem which is maintained by the main stakeholders of the ecosystem. Even though it is started by a group of people or one person, we don't know. But the governance structures of the Bitcoin is owned by the people who actually involved with it, right? So mostly the Bitcoin developers, and there is a developer community. Even if you want, you can involve into that, and you can play a major role. There is no one stopping, and no central authority, and other kinds of things. So sometimes people give Bitcoin as an example of the first DAO, but and again, people who don't agree that Bitcoin is a DAO, they bring up this issue saying that, okay, Bitcoin is evolved as a DAO, you can say, or in terms of the decentralized governance, but it was not formed as a DAO. They give the reason saying that a DAO should be written clearly at the time of formation, saying that what are the rules for governance and who can decide it. And if possible, everything should be implementable in a smart contract way. So they argue that these rules can be implemented as smart contracts and things like that. So, but it gave the one of the first organization which is formed on these principles. This is called DAO. So the DAO. It is a funny name, but it also linked to hack on the Ethereum. So we will see a bit later. So this is one of the first organization started in 2016, almost 1 year after the Ethereum has been launched and things like that. So it was Ethereum blockchain was in the very nascent stage, right? So the basic idea is to start a venture capital firm, crowd-funded by the people, right? So the basic idea is you can invest some money in the DAO, which is a decentralized organization, and then you can be part of this venture capital system, which can fund projects on the Ethereum blockchain, especially the projects which are mainly work in the decentralized principles, and also which deploy applications using smart contracts on Ethereum, right? So that is the main purpose, to fund these projects on Ethereum. That was the main purpose it started. And of course, it got failed. We'll see this hack, the DAO hack, when we see a couple of slides later. But it also gave inspiration to many other ideas like this. For example, DAO stock, which we have seen before, the video from the DAO stock and things like that. So basically, these are the models which actually try to come up with some kind of software system, which you can use it as a template to develop collaborative applications, decentralized distributed collaborative applications, building on the principles of the decentralized autonomous organization. So what are the characteristics? So DAO enable people to coordinate self-governance themselves. So there is no decentral governance. The governance is maintained by themselves, right? So it's called the organization. And most of the time, that is the main requirement. So the DAO source code is deployed as a blockchain on the blockchain in the form of the smart contracts. For example, how to do the governance and how to take decisions, and all these rules will be written in the form of smart contracts, because you deploy them on this blockchain, which is transparent. That means anybody can see it. And not only that, since you write it on the blockchain, so they are immutable, right? So you cannot change these things easily and stuff like that. So that is the basic idea. So self-govern, and then again, based on the different types of the characteristics you can get, sometimes you call it as self-govern, self-organizing, and peer-to-peer, and democratic control, and many things can happen. But having them on the blockchain and all these governance rules written into that, it will also bring the transparency and other kinds of important characteristics the underlying blockchain offers. Right? So let's look into this interesting the DAO hack. So as I mentioned before, in 2016, this DAO company was offered. It's basically crowdfunding venture capital firm, which is formed on the basis of the decentralized autonomous organization principles. So that means like no central governance, and maybe all the stakeholders, they will get the equal stake, and many kinds of things, right? Like, so it started like this. It was a quite inspiring thing. So it, you can say, a revolutionary project. It has raised $150 million US of worth of ethers, because it was in the Ethereum, right? Like it was hosted on the Ethereum, and Ether was you can say the currency or the monetary value of it. And it has raised almost $150 million US worth of Ether as investments. And then it was hosted on the Ethereum, which was around that period. It was 1 year old and things like that. So within the 3 months, what happened is the DAO was hacked, because there was some vulnerability in the Ethereum, the smart contract code, you can say, implementation and things like that. So a hacker actually hacked almost 60 million worth of the Ether, and it was stolen from them. It was by calling a function which actually drains money and transferring it to other things. So he was able to exploit this vulnerability. And then by 3 weeks on sale, it got 150 million from the 11,000 investors and things like that, which was the biggest crowdfunding campaigns at that time. And then this DAO hack has happened. So, and then they realized that there was a bug, right? So it's not, you cannot simply fix it, things like that. So that was the big issue. They identified the bug, but they were discussing how to fix it, because it was not easy. You have a lot of miners and other kinds of things. And it's not like a simple software bug fix where you can fix the bug and you can roll out this fix to all the computers and things like that. Then there was a lot of discussion how to fix this bug, whether you need a soft forking or where you will release a new version of the software. And then it needs to be adapted by all the miners and things like that. Whether you need a hard fork, where we say that, okay, till that point, the blockchain is valid, and after that point, they have revoked and hard forked the blockchain and things like that. So what happened? Then they identified that a guy has hacked legally, right? So, and then he drained almost 60 million from the 150 million investment made into the DAO, right? So then it was a big issue. And then they were trying to understand how to fix it and stuff like that. And also it's a big embarrassment for the Ethereum, because this contributes to 14% of all the Ether at that point of the time. And it was only 1 year old. And then it was in the nascent stage and things like that. So there was a lot of discussion and a lot of doubts raised about the credibility and the performance of the Ethereum and things like that, right? So, and then they were trying to argue, saying that, yeah, these funds were stolen. But the guy who hacked it, he was saying that, no, I didn't steal. I obtained in a legal way, because your smart contract has a bug. I just invoked it. I took care of the vulnerability and I got the money into my account. And how can this be treated as a stolen kind of thing and things like that? And then they were discussing about, okay, maybe a soft fork could fix it. A soft fork means make a quick fix to the software and roll it across all the miners and all the users who use it. Ask them to switch to the new version of the code and things like that. But it was not easy, because this guy or this entity who actually attacked the DAO, then they were trying to bribe some of the miners so that not convincing them not to roll into the software fork, right? So then there was like because you need to get consensus of all the miners to move to the next version. Otherwise, it doesn't happen, right? You might roll a soft fork by releasing a new version of the software, but what happens if only 50% of the miner or like 30% of the miner have adopted that, and still 70% of the miners still use the old software? Then you will end up with a big challenges and stuff like that. So there was a big debate happening at those point of times, like the Ethereum project's leadership and things like that. Then finally they released a soft fork. But again, there was another bug discovered in the software update, right? The software, they also identified a bug in the soft fork, which actually resulted into a very hard fork. So what is a hard fork? So basically, they say that they say a cutoff point, like when this hack was happened, right? So basically, what happened is this guy who attacked the DAO, he transferred his Ether to his account, right? So using he transferred the Ethers, which was invested by the investors in the DAO company, and he made transfers to his own account, or the accounts controlled by him. And then what they decided is they put a hard fork before the happening of this attack, and then that was the point of hard fork. and asked all the miners and the users to move to the new fork, because the new fork doesn't, it roll back all the money transfers. So that means now you have a two forks. The new fork, where most of the people have implemented and adopted, which contains this rollback of the money, but you still have some people who didn't adopt this hard fork. They still run the old fork, right? Pre-forked version and things like that, which is called Ethereum Classic and things like that. And then they control, I think, around 8% or something like that of the Ethereum at that point of time and things like. It will continue for quite a long time and stuff like that. I don't know whether they still have it in Ethereum Classic. I honestly don't know it, but still they contain around 8.5 million. They are able to grab 8.5 million US dollars worth of Ether and the following attacks and things like that. But again, the main important thing is this has created a lot of doubts on the performance of Ethereum. One thing. So people were realized that it is so easy to attack the cryptocurrency platforms or the blockchain platforms. So that was one of the biggest issue which they identified. And then people also lost faith in the decentralized autonomous organizations and things like that. Then they thought, okay, maybe these kinds of things can happen and stuff like that. So it's a bit, you can say, setback in the beta versions of in the initial versions of the 2016 and 2007 and how these hackers happened, right? So luckily Bitcoin was not hacked because again, when we discussed about Bitcoin as a cryptocurrency, we said that luckily Bitcoin has built into a big ecosystem, or you can say has grown up into a stage where it is beyond hackable, you can say. Because if you want to hack the ecosystem, you need to have millions and millions of dollars spend it because it works on this proof of work and other kinds of things, which made it impossible to hack it, right? So, but on the other hand, Ethereum and other cryptocurrencies, they also have the similar kind of problem. When they are in the nascent stage, early stages, they could be susceptible to attacks on them. So Ethereum happened like this, and which also hit this DAO kind of principles and decentralized, the foundations of the decentralized organizations. Okay, any questions so far? Otherwise, we can call it a day. So we are almost coming to 9:30.
No questions, sir.
Okay, then I copied the recording, last week recording also into the folder, and you can find it, and the slides already copied there, and I will also copy the recording to the same folder. Next week, I think let's look into, I think we are going to look into the NFTs and other kinds of tokens, ERC tokens, and then we'll look into some of the smart contracts platforms, like what are the other platforms which we have, and then focus more on the Ethereum. Okay, have a good night, and then see you next week.
Yeah. Thank you,
Thank you,
Professor.
sir.
Yeah.
Thank you.
Thank you.
Bye.
Thank you.